So we'll try and make this quick. This experiment was pretty straightforward. We already looked at isobutyryl chloride last experiment, so if you need any clarification on that, you can look for it. In any event, these are your sp3 carbons with a hydrogen on it stretching. This doublet, so to speak, is your carbonyl stretch, the C double bond O stretch. This one here at 1235, we talked about it, thinking it might very well be thionyl chloride. One of the ways that we could prove that is if we had a student who had a very low peak rate here, or if we had pure isobutyryl chloride, we could actually run the IR and then on a solution, and then we could start adding thionyl chloride to it to see if this peak in particular. Thionyl chloride by itself has a slightly different number than this, but sometimes compounds have a certain interaction with each other that you can get a little bit of variation on that. So that's one of the ways we could take a look at that. The product, isobutyramide, 1640, that's obviously the carbonyl stretch of the amide, 2970, 2933, those that are just to the right of 3000, sp3 carbons with hydrogens on them stretching. The two big fluffy things, 3357, 3184, those are obviously the NH2 stretching, the nitrogen hydrogen stretching of a primary amide. 1640 is the carbonyl, we already mentioned that. The rest is fine as far as I'm concerned. The NMR, we already talked about that last time, so you guys should already know about that. This should be a septet, and it belongs to the single hydrogen right in there. The two methyl groups, there's 6 of them, is this doublet. When we look at the product, or sorry, the carbon of isobutyryl chloride, we've already done that. The tall one here, the two methyl groups, this is the methine carbon right there in the middle, and then the carbonyl carbon out at 177. We go on to our product, which is isobutyramide. Now, this one, you can see right away, say there's a big peak when this student ran it, 7.27, it's a singlet. That actually ends up being the tiny peak associated with chloroform D, the NMR solvent. And the reason why it looks so big is because the amount of isobutyramide that dissolves in here is very small. When whoever ran this spectrum, they also had some TMS, and you can see how tall that TMS peak is. But other than that, we definitely expect only 3 signals. The methyl groups should be a big doublet. The methine, that'll be another one, be a septet. The 2 hydrogens on here, if you see them. Some people won't see these absorptions at all because it's so broad and flat, you can't see any of them. But in this one, you can see that very broad bump or hill come up to 1.66, close to being 2, but those for this student obviously is the NH2. These ones would be just like the isobutyryl chloride, and the carbon is going to look pretty much the same. Now the only thing, word of caution here, is I ran this one, little bit of deuterated chloroform solvent plus dimethyl sulfoxide. Both of these have their own characteristic little bumps in the carbon. See that little triplet? That's the CdCl3 at 77. That's the solvent reference. This ugly septet is actually from DMSO solvent, so that bump and this one don't belong to the compound. And just like before, for carbons, you expect 1 for the methyl groups, 1 for the methine, and 1 for the carbonyl. The carbonyl is out at 177 yet again. You have the shorter methine carbon, and that's your 2 methyl groups right there. So that takes care of that.